All right, guys, this is 2.5 part B, and only AP needs to watch this video. On level, you're welcome to if you would like to, but feel free to skip to part C if you don't want to sit through this problem, okay? So this is a problem specifically for the AP class. All right, here we say the complex number z equals 1 minus 2i is a zero of that function. Find the other zeros and write its linear factorization. So in this one, they gave me one of the complex zeros. Now keep in mind, we talked about the complex conjugate zero theorem, which says that if you have one imaginary solution, you're also going to have its conjugate. So what we're going to do with this is we are going to end up actually figuring out what exactly that would factor out or multiply out to. So let's look at what this imaginary situation is going on. We have 1, 0 here, x minus 1 minus 2i, right? That's going to give us a factor. But then the other one is going to be its conjugate, so x minus 1 plus 2i. All right, so what we're going to do is we're going to multiply this all the way through so that we can see what what this would be compared to what we are supposed to be working with. So I'm going to distribute through that negative x minus 1 plus 2i, x minus 1 minus 2i. And then we're going to just multiply through. X times x is x squared. X times negative 1, negative x. X times negative 2i, negative 2ix. Then multiply through the middle number. Negative 1 times x is negative x. Negative 1 times a negative 1 is a positive 1. Negative 1 times a negative 2i is a positive 2i. Then we're going to multiply the last one through. All right, we're going to have 2i times x. That's 2ix. Then 2i times a negative 1, negative 2i. 2i times a negative 2i, that's a negative 4i squared. I was going to go ahead and change it to a negative 1, but I'm going to wait. All right, so here we have x squared. Combine our like terms, okay? So we've done that. I'm going to cross these off as we go because it is kind of ugly. So we did that one already. Now we have negative x minus x, and those are the only ones like that. So that's a negative 2x. Those are done. Negative 2ix, and then we have a positive 2ix over here. So those are gone. We have a 2i minus 2i. Those are gone. Then we have this plus 1, and then we have minus 4 times negative 1. Clean this up just a little bit more. Negative 4 times negative 1 is a positive 4. Plus 1 is 5. Okay? All right. Here's what we know, right? If these two were zeros, right? That's what we know. We knew these two were zeros. Then we also know that this would be part of its factorization before it broke apart into those, okay? So what we're going to do is see what is it that we would need to multiply times this to get the function we're working with, which requires us to do some long division. So let's do that. We have x squared minus 2x plus 5. We're going to divide that into this function up here. Now be careful because there's a missing value. There's 4x to the fourth, but then they don't put a cubed term. So put 0x cubed. Then we have plus 17x squared plus 14x plus 65. Okay. All right, we're going to work through this division. Remember, the way that we work through this is we say how many times does this leading term go into this leading term. X squared goes into 4x to the fourth. 4x squared times. I'm losing my mind. Hold on. Another way to go about it is to ask yourself, x squared times what gives you 4x to the fourth? That'd have to be 4, right? 1 times 4 gives me 4. and then x squared times x squared gives me x to the fourth. So that's where we're getting this number from. If you're not sure what I'm doing, go back to the section 2.4 part A, and you will see us go through long division again. Okay, then we're going to take this top number and multiply through the divisor. So 4x squared times x squared is 4x to the fourth. 4x squared times a negative 2x is a negative 8x cubed. 4x squared times 5 is a positive 20x squared. And then what we do is we take this and we subtract that from the line above. Okay. So the 4x to the fourths cancel out because you're subtracting them from one another. Here we have 0 minus a negative 8, which makes a positive 8x cubed. We have 17 minus 20, which is a negative 3x squared. Then we're going to bring these other numbers just straight down. So 14x plus 65. Now we're going to say x squared times what gives me 8x cubed? Well, that is 8x. 8x times x squared is 8x cubed. 8x times a negative 2 is a negative 16x squared. 8x times 5 is a positive 40x. Okay. Again, we're going to do this thing where we subtract this line from the one above it and bring everything down. So these guys will cancel. Negative 3x squared minus a negative. So minus a negative causes us to add the 16. So think negative 3 plus 16, which gives us 13x squareds. We got 14 minus 40. That's a negative 26x. And then bring down the 65. Now we're going to ask ourselves, how many times does x squared go into 13x squared? Well, that is 13 times. 13 times x squared, 13x squared. 13 times a negative 2x, negative 26x. 13 times 5 is 65. And so if you notice that these two things match, when you subtract them, they'll just cancel each other out and you have no remainder. Okay? So what I know is, right, this thing that we had found, that this is f of x, right? That thing that we had found earlier by multiplying out our complex numbers, if I were to multiply that times my quotient here, then I get the function. Okay, now we know that this function right there, or this little part, breaks apart into our imaginary numbers, but we don't really know what's going on with this guy right here. And so we've got to figure out how to factor that thing. Okay. Now, it's a bit of a nightmare. My thought when I look at this is that I don't really feel like trying to factor that by hand. And honestly, it's because it won't actually factor because it's also complex. So what I'm going to do is I am going to plug this into our, I'm going to plug this into our, the quadratic formula, and that will end up giving me the zeros for this section so that we're able to show that all the way factored out with the complex zeros, okay? Okay, so we're going to go off to quadratic formula land. Remember, that is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. In this situation, this is a, b, and c. So we're going to plug those into our quadratic formula and see what we get. Okay, this is negative 8 plus or minus the square root. 8 squared is 64. Sorry, I should probably write that all the way out. A lot of times I do part of it in my head, so I don't have to do as much work. 8 squared minus 4 times a times 13, all over 2 times 4. So this is negative 8 plus or minus the square root. 8 squared, like I said, this is 64. I went ahead and did the math for this because I wanted to kind of keep this part shorter. So when I multiplied this out and then subtracted, I got negative 144 under the square root. And this is all over 8. Right, negative 8 plus or minus, if you square root this, you will get 12i over 8. And then we can see this as negative 8 over 8 plus or minus 12i over 8, which is oh, good Lord, I'm so sorry. Negative 1 plus or minus 12 divided by 8, you can reduce that by 4 on top and bottom, which makes 3/2 I. All right, see how lovely that was. Okay, I probably should have worked that a little closer to the margins over here, but it is okay. All right, so I know that these are zeros, and we can use those in our factorization. So the question originally, let's go back and make sure we know what the question was. Okay, we're going to find the other zeros and write the linear factorization. And all that's asking us to do is show it all the way factored out, even if it's complex. Okay, so let's see what we're going to have here. We knew from the beginning, okay, this guy is what I got from multiplying these two out. So what I'm going to do is I'm going to take these two, and we are going to replace this with those two because that is what it is factored all the way through. So I'm just copying it down from where it is higher on my paper. Okay. Kind of writing small because I know I'm going to run out of space. Okay, now we also are going to have the other one factored out, but we got that value from doing our quadratic formula. Those are our two zeros we can get from this guy right here. So this is going to give us x minus negative 1 plus this. Three halves. I am sorry, I'm writing tiny. I'm going to still run out of room. Okay, I'm going to just put this down here. Then the second one, it would get multiplied by x minus negative 1 minus. Okay. That is its linear factorization. I'm going to write it out just a tiny bit prettier down here so I can see it so I don't run out of room. This was, again, f of x equals x minus 1 minus 2i. Now we're actually missing something here. I don't know if you guys know if you have noticed it or not. I'm going to go back and add something in just a second. And one more. I'm still going to run out of room down here. Goodness. I was trying to write it neater, but I'm going to run out of room because this is like shiny over here. X minus negative 1 minus 3/2 I. Okay, we made it. Okay, we are missing something. So I'm going to run back up to the top. I want you to think about if you multiplied all this out, x times x times x times x, you're going to end up seeing a x to the 4th power. Go back to your original problem. Do you see how the leading term is supposed to be a 4? I'm missing something here because in doing my quadratic formula, it kind of made it to where we can't see that very well. So what we need to make sure that we do to see that is multiply by a 4 at the beginning. Now, there are some people who like to use this to prevent having these fractions. So your textbook, if you look at the answers in the back of it, sometimes they like to do that where they can use the number in the front to alter these fractions and make them maybe not fractions. And I'm going to show you how to do that real quick. What they like to do is instead of putting the 4 in the front, they might embed it in their little factors where the fractions go. So I'm going to rewrite once more. 1 plus 2i. Can you imagine having to do a problem like this on a test? Okay. So what I can do is I can actually break this apart. You see how these fractions are over 2? Well, I can also break 4 apart to be 2 times 2. So look at this. If I broke this and said, okay, well, let me put one of the 2's here. X minus negative 1 plus 3 halves I. Then what if I put the other 2 over here? Okay. So if you do it like that, then when you distribute this 2 through, you won't have a fraction anymore. So some people like to do that so that they don't have to see the fractions. Honestly, I don't really care either way personally, but if you're checking your answer in the back of the textbook, they might do that. So this would be 2x, and then I'm going to go ahead and distribute it through this part as well. So we have negative 2 plus 3i. And then over here, 2x minus, we'll go ahead and distribute it to the next part too, negative 2 minus 3i. And again, the whole point of that was to try to avoid having the fractions. So some people like to see it without that. That's what it would look like. Okay, so yes, there was a reason I wanted this just to be AP and not have the on-level worry about it, but I wanted to also run through it. So this problem, I don't know, even if I zoom out all the way, I don't think you can see the whole thing. It's most of it, but still you don't see the beginning. So it is a lot. It's a lot of work, right, to do one like this. So just keep in mind when you're working problems, sometimes these upper level math classes, they really can take a lot of space and be pretty time consuming. So, all right, guys, that is it for this video. Make sure that you go watch part C. That is going to be a whole lot more simple than what this one was. If you watched it all the way through the end, give yourself a round of applause, a pat on the back. Good job. And I'll see y'all in the next one. Bye.